Okay, so we will look at a little more theory about linked lists before going into the pseudocodes and algorithms. So I said every element in a linked list has two parts, an integer and an address. So how is it possible for one element to have two parts? Typically the data types we see in a C program, int, float, boolean, double, all of those are atomic types, right? As in they can only hold one value. So how do you make one element store two values, that two, one value being an integer and the other being a pointer? That is exactly what we use struct for. So struct is a concept I'm sure you've learned in C programming. So we create a structure in which we have two elements. One is the data, the integer part, and the other is a pointer to another structure. So this is what, so first of all, the elements of a linked list are called nodes. So the technical term for an element of a list is node, and this is what the syntactic or programmatic definition of a node is. So for example, if you take a struct student, you have int roll numbers, character array, name, int marks, and so on. Similarly, if you take the struct called node, it has two parts, int data and struct node star next. So now you're defining struct node in terms of struct node. That might sound a bit confusing. So this is what you call a recursive definition. A pointer to a node inside a node itself. So recursion in functions we studied, right? So you have a function and within that function you call the same function again under certain conditions. So this is similar to that. So you have something called a struct called a node, and within that structure one of the elements is a pointer to another instance of the same structure. So it might seem a little sort of confusing right now. If you're not able to make sense of the recursive definition completely at this point, it's okay. You don't need to know this code right now. You will learn this formally in your data structures course. I've just given it to you so that you understand how we are able to put two things, an integer and a pointer, within the same element or same node. That is by means of a struct. So each element of a linked list, first of all, is called a node. And how is a node defined? You define it using the struct functionality which you have studied in C. And this struct node has two aspects. One is the integer variable data, which stores the actual elements of the linked list, and the other, struct node star next, points to the next element in the list. It is a pointer. So a singly linked list is called so because there exists only one link from a node to its next or to its successor. You do not have a link from the node to its predecessor. So coming back to this picture, here you have the data and you have the pointer to the next node. So there is only one link between any node and any other node. There is a link from a node to its successor. You do not have a link from a node to its predecessor also. So if you had that as well, it would be called a doubly linked list. So there you would have data, previous and next. So you would have two pointers. So that is beyond the scope of your syllabus right now, but the point I'm trying to make is why it is called a singly linked list, because there is only one link. And also because you only have a link from an element to the next and not to the previous, you cannot traverse in reverse very easily. So you can go from element A to B to C to D, but not vice versa. It's not very easy in a single linked list. It is possible using recursion and all, but it's not very direct. It's not a direct thing. So yeah, the first node is called the head and the last node is called the tail. So yeah, head, again, like I said, whenever you work with a singly linked list, you will be given the pointer to the head usually, and using that only you have to traverse and do whatever you want. And the last node is called the tail node. So because the tail node has no next, its address part points to null. This again I mentioned in the definition itself. So in your last node you will have a data part and the address part will just say null because there is no next node after this. That is the tail. So while working with singly linked list, we always have access to the head, sometimes to the tail as well. But usually you will only be given the head pointer. Using this you need to traverse the list and perform the desired operations. Next, remember that the elements of a linked list do not have indices. So you cannot say linked list of 0, linked list of 1, you cannot access them in that way. So the pointer is the only way to access the elements of a linked list. So basically this was just a quick overview of some basic points which you need to know about a linked list.